Now let's talk about multiplication and division. Okay.
Oh, okay, I got it now.
All right. So this is what we call division, right?
Yeah.
That's we're taking a 4 and dividing it by 2, correct? But that's the same thing, right? Yep. And this is the kind of multiplication division we do in this class. Okay? We multiply and divide fractions. So I'm not going to spend a lot of time with other kinds of math that we won't really need to do in here. We're going to go straight to fractions and multiplying fractions, okay? Fair enough? All right? So let's start with something like this. We're talking about moles a while ago, okay? So there are 12 points. Let me do it the way I'm going to teach you to do it later. Look at which. So here's a different periodic table in here in honors chemistry. I want to make sure I'm doing it the way that. Oh, of course that's not there. Well, I think it's 12.01 is the way we'll list it in here. 12.01 grams of carbon in 1 mole of carbon. Okay. Okay, so there are 12.01 grams of carbon in 1 mole of carbon. How many moles of carbon are there in 100.0 grams? Okay. Well, I'm going to show you. Don't sweat it. If there are 12.01 grams of carbon in 1 mole, that means that 1 mole of carbon equals 12.01 grams. Does that make sense to you?
Oh, yeah.
If there are 12.01 grams of carbon in a mole, then there is 1 mole of carbon in 12.01 grams. They're equal to each other. If I have an amount in my hand that comes to 12.01 grams, and I were able to figure out how many carbon atoms there are, and then divide by Avogadro's number, I would find there'd be 1 mole of carbon. Make sense? So 12.01 grams of carbon is equal to a mole. Anybody confused? All right, so we can write that. 12.01 grams of carbon equals 1 mole of carbon. Do you have your pass? Oh, okay. So what I need you to do then is to simply put that in your personal file. Okay, we've made up a file. All right. 12.01 grams of carbon is equal to 1 mole of carbon. All right, now this is only 3 numbers. It shouldn't be that hard, but sometimes it seems a little, wow, what do I do with that, right? So here's what we're going to do. We're going to find the starting amount in this problem. What amount are we actually starting with in this problem? 100 grams. Because this is just saying this equals that. It's not a starting amount. There's the starting amount. Okay? We're going to put that over 1. Okay, now if I put it over 1, did I change the amount? No, it's just making it easier to do the math here, okay? Because dividing by 1 just gives you the same answer. But what I'm going to do is I'm going to use this equality statement here, and this is called an equality statement. One thing equals another. That's an equality statement. All right? I'm going to use that to build a conversion unit to solve this problem. Okay? Now, let me sort of take a little detour for a minute and explain about equality statements and writing conversion units. Can I do that? Okay? If I know that 2 equals 2, correct? And I know then that if I put 2 over 2, that equals 1. So if I multiply 4 times 1, I get 4. And so too, if I multiply 4 times 2 over 2, I also get 4 because 2 over 2 equals 1. Right? So anytime I put 2 things that are equal one on top of the other in a fraction, it's going to equal 1. Does that make sense to you? So, for example, we used a dozen a while ago. 1 dozen equals 12. So if I have 1 dozen over 12, what does that equal? 1. So, conversion units always equal 1. Conversion units in here, the way we're going to write them, always equal 1. That's why they're called a unit. Okay? Some of y'all, anybody here in ROTC? In the military, what is a unit? Huh? Oh, well, make sure you check with Sergeant Ames on that one then, okay? A unit is any group of people in the military charged with the same task. That's a unit. They can have 2 people, they can have 2,000 people. Okay? A unit in a car. Anybody do car repair in here? No? Okay. Well, nowadays you replace whole units in cars. You know, you don't go in and replace just the bearings and the wheels. You replace the whole wheel unit. Okay? So a unit is any one thing. Okay? Well, a conversion unit is one thing. And in the case of a conversion unit, it actually equals 1. Okay? So we're going to build a conversion unit here that's going to get us from 100 grams to the number of moles we need using this equality statement. Okay? What I want to do is to put the gram side on the bottom because I'm going to match the units I'm starting with. Okay? Here's how you build a conversion unit to solve a problem like this. You find which side of the equality statement matches your starting units and species. Put that side on the bottom. That makes sense? Pretty straightforward. Find the side of the equality statement has the same units and species as the starting amount and put that side on the bottom. And put the other side of the equality statement on the top. Okay? And so, what is this fraction equal to? 1. But we're going to multiply this number right here by 1 in a way that's going to give us a new unit of measurement. Alright. Take another little detour. What does that equal to? Y. Okay. X times Y is XY. 1 times X is X. What happens to the X's? They cancel. Okay, and so now this answer is Y. Well, you know what? I could have started with X over 1 times Y over X and realized, hey, those X's and Y's those X's are going to cancel anyway and go straight to Y, right? I can do the same thing up here with units and species. Unit of measurement and the species carbon. Okay, units and species act just like X's and Y's. I cancel the grams. There's my X. I cancel the carbon. There's the Y. Okay? Make sense? And now when I do the multiplication, or the division in this case, because it'll be this number divided by that number, right? If I take this number and multiply by 1, I just get that number. This number divided by this, I multiply this number, I just get the same number. So it really is going to end up being 100 divided by 12.01, correct? Yeah. Y'all with me? I'm not leaving anybody in the dust, am I? A little bit? Well, if I multiply 100 times this number, I get 100.0 moles C. 1 times 12.01 is 12.01.
Oh, okay.
So I could have just gone ahead, I did with a division here, I could have done it here. Yes? Okay. So let's take that 100. Try to do it so you can see it on the camera. The glare is kind of getting in the way. I'm using a sort of I can get more expensive calculator out here in a minute. All right, I get this really, really big number. Oh, I'm sorry, yeah. I'm being a little sloppy. Trying to write kind of at a strange angle around that calculator. All right, now I'm left with these units and this species. So I need to include that with a number because every number that doesn't have units and species is basically not useful to us at all. Okay? Remember that 100 example? Okay. All right. Look at all those numbers. In fact, my calculator just happened to stop right there. If I had a better calculator, those numbers would keep on going. Huh? Oh, I did leave out a 3, thank you. There's a 3 right here. All right, that's okay. All right? Now, so does it make sense that I have 4 significant digits and 4 significant digits and this number has all these digits? I mean, just kind of common sense, it doesn't really make sense, right? So this number really shouldn't have that many digits, but the rules are different from multiplication and division. In multiplication and division, you're going to find the measured or calculated numbers in the problem and round your final answer to that measured or calculated number with the least digits. Okay? You're going to look at your measured or calculated numbers, find the one with the least digits, and then round your final answer to that many digits. Now, what are measured or calculated numbers? If they got units of measurement, they're probably going to be calculated. They're going to be measured or calculated numbers, okay? Somebody had to get this number from a measurement. Somebody got this number from a calculation. Now, what about these ones? Well, those ones are, well, I could go into more detail about where they come from, but basically they're counting numbers. We ignore those. Because counting numbers are infinitely significant. Without trying to explain that, just ignore the counting numbers, okay? Got it? All right. So how many significant digits here? 4. That 0 is significant because it follows a non-zero digit and a decimal place. These 2 zeros are between these 2 numbers here, these 2 significant digits, so those are significant, 4 significant digits. Got it? How many significant digits here? 4. How many digits do I need my final answer? 4. 1, 2, 3, 4. Underline everything else and round off. All right, multiplication and division. Look at your measured or calculated numbers of the problem. Find the one with the least digits and round your final answer to the same number of digits. So my final answer is 8.326 moles of carbon. And I'm putting a box around it because I got all this stuff on the paper. Helps me to find it. Yep.
Okay, so in your example you said x over 1 times y over x equals y because the x is against y, right?
Yep.
So basically in the actual conversion factor, were you like putting basically like x and the next equation x on the bottom, were you like putting those, they're similar because of the units, right? And that's why you're doing that way?
If they're the same units of measurement, you can cancel them.
Okay.
If they're the same species, exact same species, you have to be careful about that, but we'll get to that later on in the semester. Okay?
So you line them up like that because of the units, not because of...
Exactly. Got it?
Got it.
All right. Now, again, I'm avoiding giving you practice homework on these because you've got to get ready for the safety test tomorrow. All right? Fair enough? So you can expect me to give you some practice work on this tomorrow night. Okay? But do review your notes. Remember to review every night. Review your notes. Yes, ma'am. Because this number is a measured or calculated number. This number is a measured or calculated number. And they both have 4 significant digits. So I want my final answer to have 4. I counted 1, 2, 3, 4. Everything else is insignificant. Got it? All right? All right, guys. Y'all doing a great job. Sounds like. I hope so. We'll find out when we do some homework.